Now that we know how to add two vectors graphically with head to tail and then tail to head, let's put more rigor into calculating that, because eventually you want to know where the vector is heading and what's the length, what's its magnitude in numbers. Alright, so we still have the same set of vectors. We are calculating C, which is a summation of A plus B. So given that we know all about the vector A and B, again, we know all about them, which means we know the magnitude of A and the direction of A, and the magnitude of B and the direction of B. This means that we can easily find the angle between the vector A and the vector B. And this angle is necessary in order to find the angle of the vector C. Alright, so C is a summation of A plus B. We want to know the following of the vector C. We want to know its magnitude as well as direction. So this formula gives you the magnitude of the vector C. The magnitude of the vector C is equal to the square root of this magnitude of the vector A square plus magnitude of vector B square plus 2 times A times B times cosine theta, where theta is the angle between vector A and vector B. Something to note is that this angle is defined when you join the tail of vector A with the tail of vector B. So both vectors are emerging from the point, and you divide theta with that angle. The direction of the vector C can be calculated in terms of an angle with respect to a vector A. Let's call it beta. And using trigonometry, we find that a tangent of beta is equal to b sine theta over a plus b cosine theta. To enforce your learning, write, comment, or share what you have learned today and hashtag PhysicsLitUp. And subscribe to Physics Lit Up for the next video.